Determine all intervals of concave up or concave down and determine the coordinates of all inflection points, including cliffs, for the function f of x equals x to the fourth plus 2x cubed minus 12x squared minus 14x plus 20. The first thing to do is find the domain. F of x equals x to the fourth plus 2x cubed minus 12x squared minus 14x plus 20, which is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative for this. We will start with the first derivative. F prime of x equals, the first term is power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply with the 2, subtract 1 from it. Third term is power rule, bring down the power, multiply with the negative 12, subtract 1 from it. Fourth term is a constant times x, derivative will be the constant. Fifth term is a constant with no x, derivative is 0. We can now find the second derivative. F double prime of x equals, first term is power rule, bring down the power, multiply with the 4, subtract 1 from it. Second term is power rule, bring down the power, multiply with the 6, subtract 1 from it. Third term is a constant times x, derivative is the constant, and fourth term is a constant with no x, derivative is 0. We will want to fully factor the second derivative. There is a common factor of 12. Factoring that out will leave behind x squared plus x minus 2, which is a trinomial quadratic. And we can attempt to further factor the trinomial quadratic into x and x. We need two numbers that multiply to be a negative 2 and add to be a positive 1. Positive 2 and negative 1 will take care of this. We can now set the numerator equal to 0, and the denominator, if there is one, also equal to 0, and solve for all x's. Because of the x plus 2 factor, x equals negative 2. And because of the x minus 1 factor, x equals positive 1. We will now check to see which of these are in the domain. The domain is all real numbers. X equals negative 2 is a real number. X equals 1 is a real number. We keep each of them. They are both candidate numbers to be a possible inflection point. We can now draw a domain line, a line representing the domain. The domain has no left end because it begins at negative infinity, and no right end because it ends at positive infinity. We can put all candidate numbers on the domain line in order. We have x equals negative 2, and then x equals positive 1. This splits the domain interval up into 3 separate intervals. We can pick a test value in each of the intervals. The first interval is negative infinity to negative 2. We can pick the test value of negative 10. Then negative 2 to positive 1, we can pick a test value of 0. Then positive 1 to positive infinity, we can pick a test value of positive 10. We can now test the concavity in each of these intervals by plugging the test value into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version. Starting with negative 10 plugged in, negative 10 plus 2 is a negative. Negative 10 minus 1 is a negative. Negative times negative is a positive times the positive 12 is still a positive. We have a positive second derivative. This corresponds to a concave up. We can now plug the test value of 0 into the fully factored version of the second derivative. 0 plus 2 is positive. 0 minus 1 is negative. Positive times negative is negative times the positive 12 is still negative. We have a negative second derivative. This corresponds to a concave down. We can now plug the test value of positive 10 in. Fully factored version of the second derivative. 10 plus 2 is positive. 10 minus 1 is positive. Positive times positive is positive times the positive 12 is still positive. We have a positive second derivative. This corresponds to a concave up. So we have a concave up interval from negative infinity to negative 2. union, because it's happening again from 1 to positive infinity, we have a concave down interval that's happening from -2 to +1. Right at the candidate value of x equals -2, the concavity is changing from concave up to concave down. That will make x equals -2 be an inflection point. So we have an inflection point at an x-coordinate of -2. There will be some corresponding y-coordinate that can be found by plugging the x-coordinate into the original function. So y equals f of -2, which is -2 to the 4th plus 2 times -2 cubed minus 12 times -2 squared minus 14 times a -2 and then plus 20. A negative to the 4th, because it's an even power, will be positive. 2 to the 4th is a 16. Plus 2 times a negative to an odd power is negative, and 2 cubed is an 8. Minus 12 times -2 squared is a positive 4. A minus 14 times a -2 is a positive 28. And then plus 20. So we have 16. 2 times a -8 is a -16. A -12 times a 4 is a -48. And then plus 28 and plus 20. 16 minus 16 will cancel each other out. And -48 plus 28 is -20 plus 20 is 0. So it has a corresponding y-coordinate of 0. Right at the candidate number of x equals +1, we have the concavity changing from concave down to concave up. That makes x equals 1 be also an inflection point. It has an x-coordinate of 1, and it has a corresponding y-coordinate that can be found by plugging the x value back into the original function. So y equals f of 1, which will be 1 to the 4th plus 2 times 1 cubed minus 12 times 1 squared minus 14 times 1 plus 20. 1 to the 4th is 1 plus 2 times 1 cubed is 1 minus 12 times 1 squared is 1 minus 14 times 1 is a minus 14 plus 20, which gives us 1 plus 2 times 1 is a 2, minus 12 times 1 is a minus 12, minus 14, and then plus 20. 1 plus 2 is a 3, minus 12 is a -9, minus 14 is a -23, plus 20 comes out to -3. So it has a corresponding y-coordinate of -3. So we have 2 concave up intervals, 1 concave down interval, and 2 inflection points, one at -2, 0, and the other at +1, -3.